So hi, my name is Chris Alimo. I'm VP of Engineering here at Starboard. So I'm just going to give you a very brief overview of the product and what you can do with it, and then Kirill will go super deep with his whiteboard session. So let me just pull this up. It's timed out while we were talking. So what I'm going to connect to is an AC 4000 system that's back in our lab, and this is identical to the system that you're looking at, sitting right here, right? It's a 3U chassis. And the system that we have, that we're talking to here, is loaded up with 36 disks, okay? And by the way, what we're looking here, this is the management console for the product. So, think of it like a single pane of glass for managing all of your storage needs, all the different protocols, all within one system, right?
I like the black and white design. It reminds me of ladies.
It's a little bit of color. But yeah. So this system has 36 disks in it, okay? It's a mixture of 7,200 RPM disks, 15K RPM disks, and then 4 SSDs as well. And those are used for the write and the read cache, okay? So let's first talk a little bit about the hardware side of it. So what's in here? So basically the head unit is, like Tom was talking about before, right? 3U chassis, right? They can with 16 slots. This particular system has 2 SSDs that are mirrored for the write cache. These are SLD SSDs, and then 2 SSDs for the read cache as well. So a total of 800 gigabytes of read cache, and then the data in there is compressed as well, right? So you get a 2-to-1 compression ratio, basically. And then in the back of this, you can see all the different interfaces that we have as well. So this is a storage bridge bay architecture, right? So it's got redundant power and then a redundant controller, okay? And as part of each controller, you have all the different network interfaces, right? So you've got 8 gigabit fiber channel, 10 gigabit Ethernet, and then up here is a SAS interconnect to connect to the different expansion shelves. So the connection between the controllers and all the disks is SAS, right? So this is an elegant architecture that really makes it so that our software is portable to any hardware architecture. So we're not married to any sort of technology that's specific to any sort of server, right? This can run on any pair of standard Intel-based servers as well, as long as there's SAS connections to all the disks that you have, right? Now this particular system has an expansion shelf as well, and expansion shelf can hold 45 disks. There's disks on both the front side and the back side. So here we're looking at the rear of the unit, right? Again, it's got redundant power, SAS interconnect, and this is really just a JBOD, right? So it's a very inexpensive way to expand your storage. You can have up to 4 of the expansion units daisy-chained off of the head unit. And this particular model has a mixture of 7,200 RPM and 15K SAS drives as well.
Can you add those expansion arrays non-disruptively?
Yeah, exactly. You can add 1 disk at a time, and those disks get added into our storage pool, right? And you can add shelves at a time as well. It's not disruptive, and this software immediately makes use of the disks that are added. There's the only provisioning that you need to do is just to tell it to use those disks that you've added, right? Very, very simple. Okay, so let me talk a little bit about some of the concepts behind this, right? So the main concept from a storage perspective is this idea of a storage pool. So our system has a single pool made up of all the spinning disks in the system, okay? So there's no need for the administrator to manage RAID groups or virtual disks or anything like that. The decisions as to where to place the data are left up to the system software, okay? So really all you have to do is tell the system which disks, are you going to use when you add new disks, right? And they're automatically added into this giant pool of storage. New data that's written is now written to the new disks as they come online. Right?
When you extend the pools, what does it do with the disk, the stripes on the disks?
Yeah, so as you add disks, as you add shelf, then the pool is automatically extended to use those new storage resources.
But we're not doing any rewriting of existing data. We're not rebalancing. Or,
Yeah, right.
You know, writing data to the new data will be written to the new drives, but the existing data stays in place.
Right, right. So it's very easy for the administrator. There aren't any decisions to make about, okay, what disks do I place these volumes on? What disks do I place these other volumes on, right? There's just one big pool. The only choice you make when you are configuring volumes of the system is what type of disk to use, whether it's 7,200 RPM or 15K, so you have that decision. And then what's the stripe width that you want to use for that volume, depending on the efficiency, you know, the number of parity blocks that you want to have, and then what's the chunk size as well. So those are the only knobs that you turn when you create a new volume, right? And then the system finds the appropriate storage that's available and automatically writes new data to it. So in this case, we have a pool made up of 32 spinning disks, right? And there's really nothing to manage from that standpoint. Okay. Now the other concept we have is a volume. So the granular item that you manage is a volume, right? And so you have volumes for iSCSI, volumes that are shared for fiber channel, NFS, and CIFS with file systems on them, right? And so now the other thing about our storage pool is that everything within the system is thin provisioned, right? And that includes volumes and snapshots. So there's a volume map that describes the mapping between volumes and where the data is stored within the pool. That also applies to snapshots as well. And so from that standpoint, volumes and snapshots are essentially the same thing. It's just a list of pointers to where the data is. And so what that allows us to do is when you create a snapshot, basically there's no data movement at all, right? It's a zero copy snapshot. We're just creating another volume map with pointers as to where the data is, right? So in this particular case, we've got 10 different volumes on the system, right? And there's 6 offline snapshots as well. And these, pie charts tell you, how is the storage consumed within the system, okay? And then over here, we have the different interfaces that we support, right? So it's very easy to create a new iSCSI LUN or a new fiber channel LUN, right? And then NFS and CIFS as well. So for example, here's, we can see in this particular system, we have a handful of CIFS shares. And these are shares that are actively running right now and mounted as well, right? So, and that includes snapshots. So this is a snapshot that was promoted and is mounted by the system as well. So.
Whether you're using the 15K CDs or the slower ones, does it automatically figure out what to use? I mean,
yeah, so when you create a volume, you say, what type of disk do I want this volume to reside on, right? And then the system will go and find available storage, within that class of drives.
But I mean, is it optimized as far as that goes then? Is it going to be on the slower or the faster hard drives?
Well, so you make the choice as to which one you want to use.
You tell it where you want the volume to reside. Do you want it on 15K or 7,200?
But you can have the volumes that have both, right?
Yeah, a
No,
volume
you
could
pick one or the
potentially
other.
have both, but it's probably not wise to mix the speeds. You're going to kind of default to
Okay.
the.
But you don't auto-tier betbetween different speeds.
We don't
Yeah.
auto-tier.
No.
No.
Yeah.
In this particular case, there are 10 volumes on the system. Some of them are stored on 15K only, and some are stored on 7,200 RPM only. So.
Well, if it turned out to be that your decision to put it on 7,200K drives was bad, you can move it, of course.
Sure.
Yeah.
Mm-hmm.
Yeah.
Yep, that's fine. Right. So you can see, in this case, we've got.
I should point out, and I may be opening a kimono a little bit here, but the reality is the performance difference in a volume on 15K versus 7,200, our system kind of masks a lot of that performance difference because we're making use of the cache as well, right? So.
Right. So like here's a volume exported via fiber channel connected to a host, So really what you're looking at is, we've got, the 4 major storage protocols, all within one box, managed via one pane of glass. So one other thing I did want to point out is the way that we use the SSDs within the system, right? So, and Kirill's going to, talk about this in great detail, but basically we have SSDs that are used on the write, which we call write back, and then SSDs that we use on the read, which we call spillover, right? In this particular configuration, we have 800 gigabytes of SSD for the read side or the spillover. And so this basic chart tells us how much of that is being used, right? And so you can look at this and see, well, when I'm getting close to the top, maybe I need some more cache. The system needs more cache in order to deliver the performance that my applications are looking for. So all you need to do then is buy another SSD and plug it in, and now you've automatically grown your the performance aspect of the system, right? And so, and the system, of course, automatically manages how that resource is used. But basically, it's from a pay-as-you-grow perspective, it's not just capacity, but it's also performance. You can add performance one SSD at a time. And this is really enabled not just by the system software, but also by the hardware architecture that we have. The fact that we're using an industry standard platform with SAS interconnect to the disks, makes it very easy to scale the performance. It's not like we're using PCIe cards or anything like that, where it's difficult to upgrade. So.
What kind of performance jump would you be looking at when you scale like certain more SSDs into the system?
It really depends on. It's a difficult question to answer, right? Because it depends on the application and where the bottlenecks are. But the basic answer.
Baselining and say something like just say, well, if you put this in there, you can expect a minimum of.
Yeah, well, here's an example. So, we've been doing a lot of testing using an Exchange environment, and Tom showed you this, some of the slides there, right? And so there's a Microsoft standard test that's called Jet Stress that's used, for Exchange benchmarking. And we actually tested at different, levels of SSD for the read side, and we were able to observe the increase in performance, So in one particular case, when we added another SSD into the system, we saw like a 25% increase in the overall performance through the life of that test.
Yeah, those questions. The answer is always it depends.
Yeah.
Because when we add the SSD is a performance element that's shared by all of the workloads on the system. And some of those workloads may be really small block random IO intensive, a database, and maybe you've got a very big database, and so you get a huge benefit out of it. But then perhaps you've got a lot of large block sequential data like video or something sitting on the hard drive that doesn't need to be cached for performance. You're probably not going to get the benefit out of it then, right?
Is there like a cache hit ratio counter?
I don't know. Do you know the answer to that, Kirill?
Not currently, but it's definitely the information that we have available. It's not available through the UI, but you can tell that you're running out simply because you're, overfilling that capacity and your performance goes down. This is where the good thing is that we don't sort of lock you into that. You can just add more performance, but by throwing in more SSD.
Right, but if you had a cache hit rate kind of counter, then I could go, well, things have gotten slower and my cache hit rate went from 90 to 80. I'm like, time to add more cache.
Yeah, that's a great point, Howard. That'd be another good tool to help the user understand what they add.
Because in a caching system, whether more cache is going to help depends on
that's right.
how much of your data is hot and how hot it is relative to the cold data.
Right.
Well, the reality of it is we're trying to minimize the amount of management that the user is doing. So if they are nearing the capacity on the cache, or they're experiencing shortage of cache, they will know from that diagram, and they will know that adding the SSD will help. Essentially, that's as simple as that. Rather than analyzing a bunch of numbers that they may or may not be willing to look into.
Mm-hmm. So, like, here's an example. So, we were able to achieve 4,000 transactions per second in this particular Exchange environment with 1 terabyte of read cache, right? And we did run the same test with less read cache, and we saw numbers in the 3,000 kind of range as well. So that's enough where we can demonstrate the effect of adding more SSD into the system.